Wonderful. So thank you for the introduction. So my name is James Robey. I look after the sustainability agenda for Capgemini. So Capgemini is a global IT and engineering services transformation business. We have around about 350,000 people spread across 50 countries. So we have about, our largest country is India, where we have about 180,000 people. Here in the UK, we have around about 15,000 people. Global revenues are around about 22 billion euros. That gives you a sort of sense of the scale of the business. And we work with a good proportion of the Fortune 500, helping them with everything from running IT, developing IT, right through to much more strategic business transformation and strategy projects. I've been with the business now for around about 25 years. I spent the first 7 or 8 years of my time with Capgemini looking after clients, worked in a range of sectors, so public sector, finance sector, manufacturing. And then around about 2003, 2004, started to have a look at the overall sustainability agenda, started to think about what that might mean for our business. And as a result of that, was invited to build a sustainability program, first for the UK business and then more latterly the global business. And we can talk a little bit, if you like, about what we're doing at Capgemini. I've put together, I've just got a whole load of slides. What I was going to plan on talking about today was start with sort of thinking about carbon, thinking about where we are in from a global perspective, talk a little bit about the IPCC, the latest IPCC report, AR6, and what that's telling us in terms of carbon. I was then going to talk a little bit about some of the macro trends that we are seeing at the moment and how those macro trends are impacting corporate businesses. And then I put together a few slides which were around kind of building solutions and how technology can potentially act as a vehicle for driving climate solutions. That's what I had in mind. Hopefully that broadly aligns to what you were expecting this afternoon. And please do jump in as we go through. So the more interactive it is, the more interesting it is. I know it's easier to interact when we're all in the same room, but please do use the tools or wave at me or put your hand up, and we'll go from there. Just can I check, Karima, in terms of timing, how long would you like me to talk for? How long would you? When do we need to wrap up?
We have allocated 1 hour and a half. So as much as you feel comfortable, given that there will be some questions, I suppose, expected from students.
Fantastic, that's fine. I will make sure that we are wrapped up ahead of 6 o'clock, as I know I'm standing between you and the weekend. So let me start with a little bit of climate background. So the IPCC process has delivered a number of assessment reports over the last 2 decades. The last of these assessment reports, AR6, the 6th assessment report, concluded in March this year. They're effectively, the findings were presented in three stages, and then the final synthesis report was presented this March. And I thought what I would do is I would pick out from that report what I think is probably the most important table. And apologies, I will unpack it, a whole load of numbers for Friday afternoon, but what I'll do is I'll try and unpack that table piece by piece, and then sort of use that as framing the conversation we need to have, thinking about sustainability and transformation. So I guess the reality is everything here starts with the carbon cycle, and CO2 is in continuous flux, if you like. It's continuously sort of being released from the lands, from the oceans. Plants are breathing in and out CO2 or breathing out CO2, they're breathing in oxygen. And so you've got this continuous cycle running. And so if we look back, what we're seeing is effectively an imbalance compared to historical CO2 flows. And if you look at this picture, the top half of this graph shows us the main CO2 sources over the last 170 years. So really since the Industrial Revolution got going. You can see the vast majority at the moment of CO2 emissions are coming out of fossil fuel and industry, and a not insignificant proportion coming from land use change. So that's things like deforestation and burning forestry back. So overall, that is emitting about 40 gigatons, about 40 billion tons of CO2 into the atmosphere every year. Now, the reality is that CO2 has to go somewhere, and the other half of the graph, which is in balance, shows where we think that CO2 is going. So interestingly, at least half of it is being reabsorbed into the system. You can see there about a quarter of the CO2 is being absorbed into the ocean. Oceans are actually quite good at absorbing CO2. And interestingly, the warmer the oceans get, the more effective they get at absorbing CO2. So this almost provides a buffer. Now, of course, CO2 going into the oceans is not without its own challenges. Of course, put CO2 into a water and you acidify it. And so this is partly some of the challenges we're seeing about acidification of the ocean and the impacts that's having on coral and fossil and fish and invertebrates living in the ocean. But starting point, about a quarter of all this excess CO2 we're putting into the atmosphere is being absorbed into the ocean. Second up, the land sink. So this is essentially soils and plants and everything growing. They likewise are good at absorbing CO2. Plants live on absorbing CO2. And in a sense, the more CO2 there is in the atmosphere, the easier it is for the plants to grow, the faster they grow. So again, as we see the level of CO2 in the atmosphere go up, we see actually more CO2 being absorbed into the vegetation. And then there's the residual, there's this piece here, the atmosphere. And this is the piece which is left behind. This is the piece driving, if you like, the greenhouse gas process. So about half of the CO2 that we're throwing into the atmosphere each year is left. And that's what's driving this picture here, which I suspect most of you have seen before or seen various forms of. This is sort of the NASA picture showing the CO2 level of the atmosphere over the last about 800,000 years. And what you notice here is, first of all, you notice that up until 50 years ago, the CO2 level was in a range from about 180 parts per million to about 280 parts per million. Now, interestingly, it doesn't sound a very big difference, 100 parts per million, but the difference between the two extremes, at 180 parts per million, assuming most of you are sat somewhere near London, we would be underneath the ice sheets, which had come down from the North Pole. So we would be sitting under a polar glacier. At 280 parts per million, you get the nice benign climate that our ancestors have all been enjoying for the last 5 or 10,000 years, and has enabled humanity to flourish. And then you see what's happened in the last 100 years or so with this massive spike up from 280 to about 420 parts per million. It's quite unique in terms of it's taking us certainly into uncharted territory in terms of the last million years or so. It's also uncharted just because of the speed of that transition. It's hard to see on a very compressed graph, but you can get the sense of that most of those transitions between 180 and 280 were transitions which were taking thousands of years to happen, not 100 years. If we look more specifically, this is the same chart, or a section of this chart for the last 60 years or so, and you can see that CO2 levels are the latest data in February, recently published. We're at about 420 parts per million. The black line shows the rolling average for the 12-month period. The red line, the cyclical sine wave, is interesting. It actually reflects the impact of the imbalance of vegetation between the southern and northern hemispheres. So in the southern summer, a lot of CO2 is absorbed into the rainforests, which actually then drives down the CO2 level. So you get this imbalance, and you can see that compared to last year, we were about 1.2 parts per million higher. So that's just sort of unpacks that 40 gigatons, that 40 billion tons of CO2. The reality, of course, is that, as we all know, CO2 isn't the only greenhouse gas. Methane is the most significant follow-up gas, followed by nitrous oxide, and then there are the so-called F gases. If you take the combined impact in carbon dioxide equivalent, then you get to this figure of about 50 gigatons, 50 billion tons of greenhouse gas emissions going into the atmosphere every year. And if any of you have read or watched Bill Gates talking about climate change, Bill Gates talks about in his book, there are two figures you need to know. One is 50 and the other is 0. This is precisely the 50 that Bill Gates is talking about, the 0 being the where we need to get to in terms of our net emissions on an annual basis. So moving from there, I can come back now to our table in AR6. As I said, let me break it down piece by piece. So the first piece here is the piece at the top, which says, how much CO2 have we put into the atmosphere over the last 170 years? Our estimate is around about 2.4 trillion tons, plus or minus 10%. So that's 2.4 trillion or 2,400 gigatons of CO2 into the atmosphere. And that has already driven climate change, has already driven probably somewhere around 1 degree of warming. So we're already 1 degree warmer than we were before the Industrial Revolution. I'm sure some of you will have seen the press articles in the last couple of days with predictions that we're actually going to cross the Paris Agreement, the 1.5 degree line, and probably sometime in the next few years. Interestingly, the thinking is that because of the El Nino process, we're actually going to cross the 1.5 degrees for a couple of years, then fall back. But given the current trajectory, we will then more permanently cross the 1.5 degrees, probably sometime in the next 10 years or so. Also interesting, if you think about it, we have already used 1 degree of the 1.5 degrees that when people talk about the Paris Agreement, and we've already baked a lot of heating into the system because there's some quite significant lags in the biophysical system that we live in. So that's kind of where we are. The other half of the table is really centered around this concept of carbon budgets. So effectively, how much more CO2 can we put into the atmosphere, and what's that likely to deliver in terms of climate change? So you see the 3 rows here, and 3 scenarios, a 1.5 degree scenario, a 1.7 degrees, and a 2 degree scenario, and then also a likelihood scenario. So effectively a probability scenario. So what I'm going to do is I'm going to take this scenario. So this scenario says we're going to try and hold the Paris Agreement. We're going to try and stick to within 1.5 degrees, and we're going to go for a 67% probability of achieving this. Now, I think if we knew that there was a 67% probability of any aeroplane that we got on board actually reaching its final destination, I'm not sure many of us would be joining those flights. But for the sake of this discussion, let's say that a 67% chance of survival or a 67% chance of the outcome is okay. So what that then tells us is that we can, if we want a 67% probability of limiting global warming to 1.5 degrees, we can afford to put another 400 gigatons into the atmosphere. Now remember, we're putting about 40 gigatons in each year. Of course, there's a twist here. This is from the beginning of 2020. So we've already used up probably about 3 years worth of carbon. So the reality is there's probably about 280 gigatons of budget left. So put another way, we've got another 7 years of budget if we take a business as usual approach, providing that in the 8th year we're at 0 carbon, which of course is a nonsensical scenario, but it gives you a scale of the challenge. And then the final part of the table, the scientists are covering themselves and they're saying that these figures, these projection figures, are all absolutely true, providing we decarbonize or reduce the non-CO2 greenhouse gases at a comparable rate. And if we don't, then that can significantly reduce the budget we have to play with. So that gives you just a scale of the challenge. The next chart, which again some of you might well have seen, is this this is one of the charts which is about the evolution to net zero. And what you see here is, and this one is based on the 2019 effectively being the highs. And if you look at this blue line trajectory, essentially what we're looking at here is a trajectory which says halve the carbon footprint between 2020 and 2030, halve it again between 2030 and 2040, halve it again to 2050, but then we need to inject carbon removals or carbon capture to bring us down to this point, this net zero point. Now, what's interesting, and let me see if I can quickly grab a different slide, is how are we doing against that? I don't know if I've got the slide in this pack. Let me see if I have. Maybe I haven't got the slide, so I just have to talk it. So if you think about, well, how are we doing against this trajectory? Halving the carbon emissions by 50% from 2019 to 2030. If you do the maths, it works out about 7.6% each year that we need to reduce CO2 emissions. And in 2020, we didn't actually do badly. We reduced our carbon emissions by 7.2% in 2020. So you could almost say we almost achieved the first year of the trajectory. Of course, there was a reason that we achieved a 7.2% carbon reduction in 2020, and of course, not a good reason. It was the reason of COVID and that we were all massively locked down. It seems amazing it was 3 years ago that we were all locked down and unable to leave our homes except for an hour a day. But that transformation to the system drove about a 7.2% reduction in carbon emissions in 2020. In a peak, which was in Q2, we were down about 18%. Subsequently, of course, CO2 emissions have rebounded and we're back to pre-pandemic levels. As a question, so let me.
Yeah, a question about whether the COVID causes a decrease in the energy emission, while COVID has been effective at unfortunately limiting us to working in our homes and limiting the energy consumption from the traveling. It also may have been directly caused an increase of the energy consumption from people using more devices. Since we're at home, we are using devices for entertainment and also for work. So would you like to clarify how the 12% high in energy emission is linked?
So I don't have the full breakdown. The macro level figures seem to suggest that we were about 7.2. Well, it seemed to suggest that overall emissions were down about 18% in Q2, which was when we were most locked down. Most of us in the UK were allowed to go out for 1 hour a day. You know, the global aviation virtually switched off. I think commercial aviation for passengers was down 90-something%. There was a bit more than that because some of the freight was still flying. So we did see overall impact down around 7% on the year, but you're quite right. There was a shift of energy consumption from offices to home, but net global impact was about 7%, which gives you just a scale of the level of transformation that we're talking about in terms of decarbonisation. So I thought I'd start with that because that just gives you a bit of a flavour in terms of, from a sustainability perspective, the scale of the challenge. What I was going to talk about now was some of the macro trends that I can see. You know, we're seeing from a corporate perspective, and then we can think a little bit about how that's disrupting businesses and disrupting the system. And I can talk about that from two perspectives. I'll talk about some macro trends coming in from a sort of macroeconomic or geopolitical perspective. So we'll talk there about food systems and economic systems. And then I'll also talk a little bit about the changes in the system in terms of changes in stakeholder expectations. So starting thinking about some of those macroeconomics and geopolitical trends and what we're seeing in terms of disruption, I think the first thing we're seeing is a massive disruption in the food system and the energy systems. And again, I put some disruption price, some maize and wheat prices in here. I mean, clearly this was partly driven by the invasion of Ukraine last year and the disruptions around some of the big agricultural commodities. And then there was a direct impact because of the impact, because Ukraine is a major agri country, but there's also an indirect impact because there was a massive spike in energy prices last year due to the situation. Now, when you look at the global food system, what you suddenly realize, and what this chart is showing, is just how much of our food system is now reliant on synthetic fertilizers. And you can see here kind of an inflection point in this chart between the blue line, which is global population, and the food line, which is the gray line. And if we hadn't had synthetic fertilizer, you just would not have seen the increase in food that we've required to feed, well, we're up to about 8 billion people now. And the importance of this is just the incredible correlation between the cost of fertilizer and particularly the cost of gas. So here you can see some charts from The Economist just showing you the linkage, and when the gas price went through the roof, the fertilizer price goes through the roof, which then drives agricultural commodity prices. Interestingly, there's some work done out of the University of Liverpool all around, and they've got a team there looking at agricultural sensitivity to oil price, and they estimate that for example, the milk price is 75% driven by oil. And that's just because if you think about the end-to-end process around milk production, which starts with artificial fertilizers being put onto meadows, then uses energy in the milking process, energy in the pasteurization process. The milk's then usually driven away in a diesel truck. It then goes to a processing plant where it's put usually in a plastic bottle made out of oil, driven on another truck to a supermarket where many of us will then get in a car to drive to the supermarket to collect the milk in the plastic bottle. So you can just see the incredible linkage between pretty much virtually everything in our economic system and oil, and therefore you can see these linkages. And so The Economist and The Guardian have been predicting a lot in terms of food. Certainly as we see global population go up beyond 8 billion, I think the UN is suggesting we're going to top out at probably somewhere around 10 billion. And at the same time, there's a lot of focus on degraded farming land. And therefore, the more degraded the farming land, the more fertilizer you have to put in. And then there's a vicious circle in here. So again, we're potentially seeing some quite big disruptions in the system in the farming system. So that's the first trend that we're seeing. The second trend we're seeing is a disruption coming from economic uncertainty. And I've put in here uncertainty, inflation, and potential downturn. Again, the oil prices we've just talked about driving an awful lot of activity, an awful lot of the issues we see. Again, we are all living through the joys of double-digit inflation in the UK. And this chart comes from the Business Confidence Index, and you can see that confidence index has crashed quite dramatically. Obviously, not quite as far as it did in 2009, following the financial crisis. Not as far as it did in 2020 with the initial COVID pandemic, but you can see confidence has come down, and you can certainly see that in terms of the global share prices and things like that. So there's a couple of inputs in terms of how we're seeing that come through in terms of political or potential implications. Not an exhaustive list, but certainly many are living through a cost of living crisis. Certainly a lot in this country are living through a cost of living crisis. But if you go out more globally, there are a lot of people who who are on living on the edge of affordability without seeing massive spikes in food and basic staples costs. I think I talked a little bit about agriculture. There's going to be an enormous pressure on our agriculture, and we'll talk a little bit about that in terms of how technology is making a difference in this space. But some of the calculations suggest that as the temperature goes up, certainly some of our big supply bases of food are getting less productive. So, for example, the US grain belt is predicted to produce about 10% less output of grains for every 1 degree of temperature rise in the system. I put here an increased focus on energy and resource efficiency. So again, I suspect all of us were probably a little bit more careful last winter with the heating than maybe we have been in previous years, just because of the spike in energy costs. I mean, there's some positives here in terms of, the focus on efficiency, which is a good thing, but it's a very real challenge for many businesses. And I guess the last point is, again, a moot point, this acceleration of the energy transition, hopefully away from fossil fuels, but there is always a danger towards fossil fuels. So we've seen a lot more investment going in terms of trying to find more cheap sources of energy. And so we're seeing a bit of a renaissance in prospecting towards traditional fossil fuels, which is highly problematic given what we looked at in terms of carbon. And unfortunately, is what happened last time the energy spiked after, over 2010, 2011, high energy prices led to huge amounts of investment in tar sands and oil shale and things like that, rather than investment in renewables. So I guess the jury's still out in terms of which way this will drive. So that's a little bit in terms of some of, if you like, some disruptions in the system. The other two, I was going to talk about disruptions from a stakeholder perspective. First of all, in terms of expectations, in terms of stakeholders, and then a little bit in terms of what does that mean in terms of their expectations. So stakeholder expectations, and this is some work coming out of some work I did with Henley Business School, looking at, if you like, the business case for sustainability. And the drivers, if you like, in what's driving organizations to invest in sustainability. First area is employees. I'm just going to grab some water. First area is employees. So most large organizations are recognizing that employees are getting a lot more demanding on the organizations that they're prepared to work for. And I suspect as you come out of your courses at UCL, you're probably going through a similar process in terms of, which organizations, which sectors, which industries you'd be happy to work for. So clearly, big change of expectation in terms of employees. Secondly, in terms of customers as well, you can think about this both in terms of business to business and business to consumer. But as business to consumer, we're all putting more expectations on the brands that we buy from. And in the business to business world, a lot of focus now from business to business customers in terms of the sustainability credentials of suppliers, and also questions about, particularly for companies like ours, how can we help our clients with their sustainability journeys? Customers kind of looking that direction, partners and providers, your supply chain. It's interesting, in the same way that employees are starting to be more selective in terms of who they're prepared to work for, we're also seeing some companies being a lot more selective in terms of who they're prepared to work for. So again, depending the industry in, you can't just assume that you are going to be able to access the things you want to buy just because you've got money. If you haven't got the right credentials, you might well find that some of your traditional suppliers aren't prepared to work for you. Fourth one I put here is regulators. Again, my experience is that most large organizations aren't driving their sustainability strategy because government is telling them that they have to, but government is telling them that they have to do a lot of reporting these days. So there is a regulatory aspect to organizations and how they're being driven in terms of sustainability. And then the final dimension I put here is investors. So a lot of investors are asking ever more in-depth questions. Again, there's a big change. There's a report from PwC here. You know, the level of assets under management under ESG funds is dramatically increasing, and certainly as a large corporate, we get a lot more questions and a lot more interesting and dialogue with our investors than we would have done historically, both in terms of what we're doing ourselves and how we can and how we're making a difference with clients. And it's interesting in this space. You know, why are the investors interested? Three key things I think are coming through. First of all, the investors are interested because they recognize that climate change is real and climate change is driving significant risks for big companies. So they want to know, have those companies quantified those risks and are they addressing them? Have they got plans in place? Again, this regulatory piece, we're getting questions about, you know, what's our preparedness? From a European perspective, we've got a piece of regulation coming through called CSRD, the Corporate Sustainability Reporting Directive. Anybody who's involved in reporting is suddenly realizing that the number of non-financial data points that organizations are going to have to report on starting in the next couple of years is, I'd say, tripling or quadrupling. It's an enormous increase in the number of data points which businesses are being prepared or being expected to report on. And then finally, ever more evidence around the correlation between companies with good ESG scores and good financial performance. So again, that's very much focused front of mind in terms of investors. Implications, just pulling out a few things here. The first one's interesting. I think, you know, you go back 3, 4, 5 years and people expected organizations to have a sustainability strategy, have a decarbonisation strategy, but it was almost accepted as long as you had one, that was fine. What we're seeing now is much more focus on the integration of sustainability strategies. So it's no longer acceptable just to have a carbon strategy over here, separate from your core business strategy. They have to be integrated and aligned. They have to focus more broadly, and we'll talk a little bit about this in a second, but going beyond the environment into the social world as well. Huge push on transparency. I was having an interesting debate with somebody yesterday about whether the linkage, you know, all the reporting directives and transparency. My view is I think there's a correlation rather than a causation there. You know, even independent of this wave of reporting legislation coming through, there is a hugely increased expectation for transparency and detailed transparency. So there are some key trends, key points from the third trend. Let me just talk about the fourth trend, and then we can open up and have a bit of a conversation. And the fourth trend for me is a broadening beyond climate change. So the last 10 years, there's been an ever-increasing focus on climate change, an ever-increasing focus on decarbonisation. But now we're seeing this go much, much wider. You know, based on where we started with, you know, when we're talking about the levels of decarbonisation needed to achieve a 1.5 degree pathway, I mean, I think it's exceedingly unlikely that we will achieve a 1.5 degree pathway. We're probably moving more towards a 2 degree world, if not a little bit more than that. Each incremental degree of warming is going to drive quite significant fundamental shifts in our climate system, in our ecosystem. So beyond mitigation, adaptation is becoming critical. Beyond climate itself, pollution is becoming a key issue, biodiversity is becoming a key issue, circular economy. So we're seeing a much broader focus and expectation on corporations and organizations to have broad environmental strategies. Alongside that, the social dimension is very significant as well. Lots more questions coming through and expectations in terms of diversity, equity, inclusion, human rights, labour standards, and so on. So a lot of focus on that social side, and also a lot of focus on the governance side as well. You know, whether it's board boards splitting the role of the CEO and the chair, for example, structures around audit committees, how are organizations managing ethics policies, bribery policies, and so on and so on. And interestingly, here in the UK, we have this piece of legislation from the UK government called the Social Value Act. And the Social Value Act is requiring organisations in the UK to make sure that when they're delivering work to government, they are delivering social value in addition to the core service. So, for example, you might be bidding to run the, let's make up something, the bin collection for Sheffield Council. So you might be bidding for a contract to do that. Yes, there's social value in terms of collecting waste, so that has a social positive for the city of Sheffield. But through the Social Value Act, you are actually being expected to go further than that and say, how are you going to make a contribution to Sheffield, which goes beyond just the benefits of collecting the bins? And there's a number of dimensions that you could be expected to do that. So that we see in the UK. In India, we see there's legislation called Section 135, which requires all big organizations operating in India to spend 2% of their average profits on what are called CSR initiatives. Then there's a whole definition within there as well in terms of what counts as a CSR initiative. So again, you can see there's this sort of evolving expectations on organizations, both from governments, from legislation, and from stakeholders. And then finally, I put there the interconnectedness of sustainability issues. I think what we're starting to see is people being much more aware of, just think about the interlinkages between biodiversity and climate would just be one example there. So let me pause at that point. I mean, we've got lots of things we can talk about, but let me just pause at that point to take any questions, or if you've got anything you'd like to share or reflect on so far. Jasmine.
Thanks. I don't know how to phrase this in a way that makes it sound like a not stupid question, but almost like I find with climate change and all of sustainability and what we're talking about, it's almost like, you almost like open up one aspect of it and it opens up 20 more in terms of like, oh, well, it could mean this and it could mean that and it could mean that. When it comes to kind of what we do about it and the mitigations, is it better for us to kind of keep in this like broad sense of like it's going to impact all of these things and we should think about them? Or do you think that, only by kind of like really honing in on specific things will we get to where we need to go? If that makes sense.
It's not a dark question. It's a very good question. I mean, it's really interesting. I think one of the challenges is sustainability is such an interconnected topic. I have a long-standing argument with a number of universities in terms of the way they embed sustainability, for example, into MBA programs. And I think there's still too many MBA programs out there where sustainability is taught as a 2-day elective at the end of a 2-year course. And the argument I would make is no, you need to teach it in week 1. And you don't need to have all the answers. You just need to teach and present some of the trends which are going on. And there's I have another lecture I give, which is about an hour and a half lecture, just looking at broader sustainability trends going beyond climate. And you can let the students follow it through. So I always encourage people. My first degree was economics, so I feel I'm allowed to do this. But there is something completely non-logical about neoclassical economics, which is basically all predicated on growth and growth on growth on growth, which is inherently exponential in its nature. And what we're effectively doing is we're running an exponential growth model on a finite system. And what we're now starting to see is the boundaries of that exponential growth model. So you can have great fun with economists because they really don't like to acknowledge the fact that exponential growth doesn't really work on a finite system. But the point I'm making there is, if you start to actually challenge students at the beginning of their course, you can almost let the students then engage with the different lecturers as you go through the course and say, okay, the economists, well, what does it, how does growth work in a finite system? Or, production theorists, how are we applying resource constraint to our production systems? And there are all sorts of elements and raw materials which are becoming increasingly constrained, which is essentially going to enforce the requirements of the circular economy. We can see bits of the world now where people are mining waste landfill sites just because the concentration of precious metals in landfill sites is significantly higher than you can find it anywhere else on the planet. Now, a lot of those precious metals, unfortunately, have been tucked away have been used in ways that they cannot be easily extracted. But again, it's starting to think about that. So I think, Jasmine, your question is spot on. I think universities sometimes struggle a little because sustainability is an economic issue, but it's also a geography issue. It's also an earth sciences issue, but it's also a psychology issue. We're all bombarded with advertising every day, advertising which tells us if we just consume a little bit more, if we just spend a little bit more money, then everything will be fine and we'll feel so much better. So it's a psychology issue. So you can almost take every discipline within a university and pull together the aspects which is something which I think from an academic perspective makes sustainability a fascinating topic, but also from a transformation process makes it an incredibly difficult topic.
Definitely. Thank you.
Max.
Yes, no, I completely agree with your last point, because having just done a master's, it's true that sustainability isn't not that it should be in the heart, but it's not really considered, especially in business and strategy classes. So I definitely agree. But I had a question pertaining to the Environmental Act 2021, which is sort of the subject of my dissertation. I was wondering from you, from a business perspective, an industry perspective, have you seen sort of a causal impact from the movement? And have you seen any changes in terms of business transformation as you see it and in your sort of day-to-day activities? And sort of what are the KPIs to look for as to how effective the Environmental Act is? Because obviously it tackles so many different sort of aspects of sustainability that it's hard to sort of pin down one. I was wondering what your perspectives were.
Yeah, it's a good question. So we manage, so we have an environmental management system globally under a certification called ISO 14001, which some of you may have come across, and that includes the requirement to monitor your environmental legislative requirements in every country and ensure that we are operating within those legislative requirements. So I've got a team of people who are managing that across 30 plus countries at the moment. And the reality is that the Act is there. It may be a function of the sector we're in, but it hasn't, or it's not something which is front of my mind in terms of driving our change strategy. Now, that means one of two things. That means either we've misjudged the Act and I've got a problem on my hands, or it means that the sector that we're in, because we have a relatively low environmental impacts, is not as impacted as many other sectors, which I suspect is the reality. The third possibility is that the Act doesn't actually have the teeth and isn't impacting anybody in any sectors. And again, I'm probably not close enough to the Act to be able to answer which of those three it is. I would suspect that from my perspective, I would suspect it's the middle one for us. But I can't comment on other industries and how they're responding to the Act. It's interesting because the other thing I sometimes think about is and again, maybe this gives you a framework which you could use to assess the efficacy of the Act. My sense is that businesses are probably the most efficient organisations that we have found in terms of allocating scarce resources. So businesses are, within the rules of the game that government set, businesses are probably the best we have from an optimization perspective. The capitalistic system is probably more effective than any other system we've tried in terms of allocating resources. Now, we can immediately then say they're probably not allocating resources in the right way because we haven't necessarily got the right rules in the capitalistic system. So, for example, there are a lot of externalities in the system which aren't priced, and therefore the system isn't working necessarily as effectively as we would want it to work. But I don't think we've found anything more effective than businesses in terms of driving that allocation process. So that then brings you back to legislation and gets you thinking about, well, what then makes good legislation? And where I think businesses are most effective are where they know the rules of the game, and they know the rules of the game over a long time horizon. So just to give you an example of what I think is probably quite an effective piece of environmental legislation, although not a terribly exciting piece, was UK landfill tax. So it was introduced 20 plus years ago now, I think. And basically it said there will be a tax on everything that goes into landfill. On day one, it will be a relatively low figure. So we're not going to break anybody's business model by implementing a tax which is going to destroy anybody's business overnight. But there's going to be a inbuilt inflation plus accelerator in that process. And over 10, 15 years, the price of putting stuff into landfill went from a couple of pounds a tonne to, I think it's over £100 a tonne now. And the impact of that has dramatically changed how businesses think about waste, in terms of trying to find anything they can do with waste to minimise it and stop it going into landfill. So that is an example of a piece of legislation that gave a long-term signal to businesses and gave businesses the ability to adapt their businesses over a time frame. There are also sort of examples of legislation which has been quite ineffective. So, for example, if we look backwards at the company car tax legislation, probably about 15 years ago now, we started taxing company cars based on tailpipe emissions. And we started being quite aggressive, so that if the CO2 levels went up beyond fairly low levels, then the amount of tax the employee had to pay was very high. Now, what went wrong with this piece of legislation was it got so expensive to take a company car that a lot of people said, right, I'm out. I'm not going to take a company car anymore. I'm just going to drive my own company car. And so what then happened was the next effect was the person then making the decision was no longer constrained by CO2 pipe emissions. So you might have somebody who was thinking about taking a 2-litre car through the company car scheme. They're now pushed out of the company car scheme because the tax is so high, and they're now saying, well, actually, what I really wanted was the 3-litre version. I was only looking at the 2-litre version because of the company car taxation policy, but now I'm out of the scheme. Let's go and buy the 3-litre version or the 4-litre version because I don't care anymore. And so again, that was a scheme which was supposed to drive down the overall emissions from cars in the UK. And my understanding is it actually saw car emissions go up because so many people then left the company car scheme. So I don't know, Max, if that helps you, but there's a couple of thoughts there in terms of how you might be able to frame what's a good piece of legislation and what's a bad piece of legislation.
It definitely does, thanks.
And what it also shows, I think, there is the need for the interaction between the private sector and the public sector. you need that dialogue between government and industry. And I do think there's I do think there is a lot of industry which is actually quite pro climate legislation, because actually if we have a level playing field, then we can adapt more quickly. Any other questions on anything that we've talked about so far? If not, let me talk a little bit about solutions, and then we'll have another conversation and wrap up from there. So I guess the point of this is that there are an awful lot of solutions out there already to the climate challenge. So if you think about this through the lens of impact areas, and this shows you, where 90+ % of global emissions are coming from. So 25% out of the energy system, 24% out of the agriculture system, 21% out of industry, 14% out of transport, and 6% out of buildings. So if you like, 5 key areas that we need to be thinking about. How do we transition? And then aligned with that, we shouldn't forget nature. Interesting, the UN's declared this decade the decade of nature or ecosystem restoration. And it's been estimated that we can probably reduce global emissions by about 1/3 just by thinking about how we interact with nature, how we actually use nature as to help us on the journey. So what I'm going to talk about now is a few solutions. They all come from this report Capgemini did a couple of years ago now, called Fit for Net Zero. And what the report identifies is 50 or 55 different technology solutions which could be applied today to technology. Some of it is already existing, it just needs scaling up. Some of it's sort of an innovation bet. But if we scale up the 55, then we can make massive changes. So I'm just going to unpack a few of these examples. So bifacial solar panels, basically bifacial solar panels are solar panels which can capture energy which are received both directly but also indirectly. So quite a lot of solar energy bounces off the ground and is reflected back up. A bifacial panel can collect some of that reflected energy. And actually, if you link bifacial panels with panels which track the sun, you can increase the harvest from a certain place by up to about 40%. So again, all with technology that exists today. The next one we've put in here is floating wind farms. The analysis on this was done in terms of there are around Europe, there are enormous areas where we could capture wind energy in the sea, but we could capture it within a range of, I think it's between 50 meters and 200 meters of depth. So effectively, if the water isn't too shallow, then you can attach your wind farm to the surface. If it gets more than 30, 40, 50 meters deep, it gets very expensive to attach your wind farms to the ground. But it's been identified that there are enormous areas, particularly off Portugal, and in the North Sea, where we could actually put floating wind farms. And then the third one here is CO2 capture. And again, this is down as an innovation bet. We've got organizations like Climeworks and many others who are starting to look at actually how can we pull CO2 out of the atmosphere. And we're still in the space where it's incredibly expensive to do this, but it's an innovation bet. And the aspiration is within 10 to 15 to 20 years, we're going to start to be able to pull CO2 out of the atmosphere at rates which are hopefully a lot more economic, a lot more like 50 to 100 euros a ton, as opposed to 400 or 500 euros a ton where it is at the moment. So massive opportunities in the energy space. Second space I've got here is agriculture. First one it's been dubbed Agriculture 4.0. This is effectively applying technology to agriculture. So it could be drones, it could be artificial intelligence, could be things like that. And you can lump in satellite data. We've been doing quite a lot of work with our team down in Toulouse on processing satellite data. We did one project in Scandinavia, which was about actually helping forestry companies spot bark beetle using satellite imagery. You can apply satellite imagery to finding pollution infestations of pests on crops, and then link that together with potentially much more targeted pesticide delivery through drones. So just really targeting specific, potentially even specific plants. So enormous opportunities here. And then many of you you'll be aware of meat alternatives in different companies starting to try and generate meat alternatives which have much lower carbon impacts. And having tried one or two of the offerings, they're getting closer. They're not perfect. I think in burger form you can create something which is pretty much aligned with a meat offering. Still space to go, but interesting. And then there's a second set of meat alternatives. There's a lot of people looking at from a protein perspective. Insects are incredibly high protein, so you can get a lot of meat, insect protein out of locusts and things like that. Now, I can't see all your faces to see how squeamish you're looking at the thought of a locust burger. I'm not sure it would be top of my list to try, but certainly there are parts of the world where insects are considered to be quite delicacies. So lots of opportunities there in the world of agriculture. Next one up I've got is industry. Again, starting to look at the reusing concrete and low carbon concrete. Huge amounts of energy go into the concrete process. With the course, one of the courses I teach at Imperial, we do an assessed piece of work, which is all about writing a decarbonisation strategy for different companies. And we've had some really interesting projects that teams have done looking at the decarbonisation of the concrete sector, which is an enormous part of overall emissions. I think it could be as much as 3%. Plant efficiency is interesting, and again, one of the things which probably gives me a little bit of hope is just how inefficient our economic system is. You look at the way factories work. You look at just to give you one example of that inefficiency in the system. It's probably a transport inefficiency rather than an industrial inefficiency. But think about it. If I get in a car to drive from London to Birmingham, I'm somewhere around 70 kilos. The car is somewhere around 2,000 kilos. So it doesn't matter whether we're running the car on electricity or whether we're running the car on petrol or diesel. 90-something+ % of the energy going into that journey is nothing about getting me from London to Birmingham. It's purely about getting the 2,000 kilos of car from London to Birmingham. So you can start to think about just the sheer levels of inefficiency, and that's in the transport system. And there's lots of written examples in terms of reorganizing plant efficiency. Quite often factories evolve. Small factories evolve, and new systems just get put, or new equipment just gets put where there's a space. I read a case study from one factory where all the equipment was hydraulically powered, and they just looked at the factory, and the hydraulic fluid went around this incredibly inefficient or incredibly circular route around the factory, where it had been the pipes had just been taken machine by machine, and they ripped it all out. They relayed the factory. They put it so that the hydraulics could run in one circle, and therefore powering the machines effectively in a much more effective way. They were able to reduce by, I think, 2/3 the size of the hydraulic pump, simply because most of the hydraulic pump was losing its power, pumping the hydraulic fluid around this incredibly inefficient sort of spider's web of hydraulic pipes. So again, just thinking about the level of inefficiency in the system, and that can be in terms of energy, or it can be in terms of reuse as well. There's huge amounts of plastic being made, thrown away. Actually, we can think about making some improvements in the circularity. There's some big opportunities at scale there. Transportation, I've talked a little bit about some of the inefficiencies in transportation. Again, there's a huge requirement. I was reading an article in the paper today about how the UK is lagging behind in its EV infrastructure along the motorway networks. I'm sure we've all seen the pictures of queues of cars waiting to try and charge up just before Christmas, due to just the inadequacy of EV charging. It's probably lithium ion for cars. For trucks, it's probably hydrogen rather than lithium ion, rather than batteries in terms of that transformation. Again, we need a hydrogen infrastructure. We're going with that. In the world of shipping, it's probably ammonia is the decarbonisation vehicle of choice for shipping. And again, don't underestimate intelligent routing. We did a project quite recently with a logistics company. The logistics company came to us. The actual exam question of the project was, we'd like to save 1 million litres of diesel. I suspect that the logistics company wasn't really thinking about carbon. They were thinking that 1 million litres of diesel these days costs, well, what in the UK cost you, what, £1.5 million, was up at nearly £2 million not long ago. They were coming at it from how do we save cash? So the solution was a hybrid solution. It had some logistics planning and intelligent routing in it, but it also brought in some gamification. So we put telematics into all of the trucks, and we gamified for the drivers. We put a gamification process in to encourage effective driving behaviour. Not hitting the brakes too hard, not accelerating too hard. That combination delivered 1 million litres of diesel save. It delivered 3,500 tonnes of carbon save, just doing the maths on the diesel save. And that's before you even start thinking about the reduction of wear and tear on the trucks and the embedded carbon associated with that. And sometimes it's about mindset change. I was talking many years ago now, I was talking to somebody who was running one of the big rail operators in the UK. And he said the biggest challenge they have with the high-speed train drivers is trying to slow them down. The high-speed train drivers like to go through as fast as possible, green signal to green signal to green signal, and then they'll suddenly hit a red signal or an amber signal and they'll have to slam the brakes on. And he said they've just been trying to educate the drivers to say, just bring the speed back by 3 or 4 miles an hour, then you'll hit green signals for the whole of your journey, so you won't have to use your brakes. Now, it sounds obvious, doesn't it? I was talking to somebody who was involved with Eurostar, and if you've been on the Eurostar through the Channel Tunnel, the Channel Tunnel is basically a parabola which goes down and then goes up. They were having a similar problem with Eurostar trains driving down at maximum speed and hitting a red light at the bottom of the tunnel, and then having to then hitting the brakes, dissipating all of the momentum, and then having to use a load of energy to get back up the other side. So slow the trains down so that at least you can carry the momentum on the downward leg into the upward leg, and you can start saving significant amounts of energy. So some of this stuff isn't rocket science, it's just reframing behaviors. And then the final set of solutions are around buildings. Huge challenges in the UK. I suspect most of us are probably sitting in buildings which were built many, many years ago. The challenge of deep renovating houses which were built 50 or 100 years ago is going to be enormous. But given the way the gas prices are going, unless we all want to be living in our houses at 6 degrees or 10 degrees over the winter, we're going to have to start thinking about retrofitting, next generation insulation techniques. And then final example I give for you here, which again is another example of reframing and rethinking about how we do things. There was a great project I came across in the Netherlands, and as you know, most big modern offices are great big glass boxes, and that means that there's huge amounts of sunlight coming in. What that means is there are certain corners of buildings where it doesn't matter what you do with the ventilation systems, it will always be hot. You know, that southwest facing corner office on a summer's afternoon is always going to be hot. Doesn't matter how much cold air you try and pump into it. And so what this office did was it said, well, rather than trying to do the impossible and air condition the whole building to 25 degrees, let's actually just go with the people who work there. Let's recognize that some people like it hot and some people like it cool. You know, there are some people, summer holiday, go and lie on the beach at 35 degrees, you can't get enough heat. Well, actually, why don't we use that knowledge? They gave everybody who used the office a little app that they could put onto their phone, including some of their preferences about things like temperature. And then when the person walks into the office, the app suggests to them some seats which might be appropriate for them. So that way, you don't need to air condition that really hot corner because you've got a whole load of people sitting there who are always cold and who always want it hot. So it was just a really nice way of taking a building, taking what potentially could have been seen as an engineering challenge. How do I cool this desk to 25 degrees, and turning it into more of a psychology challenge or a physiology challenge, and actually trying to align people to the right desks. So finishing up here, then working with nature. Interestingly, I mean, again, stopping chopping down forest is a great starting point. Forestry restoration and all of the projects around there is interesting. I put the seaweed economy in. This is probably less about climate, but it's just fascinating. There is a seaweed dimension there is a climate dimension, but it goes far beyond climate. One of the climate dimensions is that if you feed cows on seaweed, they produce about 30% less methane than if you feed them on regular feedstocks. So again, an opportunity in terms of using seaweed to decarbonize the production system. But there's apparently there's a whole new economy coming up around seaweed. Pharmaceutical companies are finding all sorts of substances in seaweed that can be used for treating illnesses, incredible chemical compounds. So seaweed is, I just throw out there. And then finally, thinking about how we use nature to mitigate climate risks. So whether that's, you know, even things as simple as planting more trees so that when we have shade as we walk down streets and things like that, planting trees so that air conditioning systems are in shade. The number of air conditioning systems which are in direct sunlight means that they just take in so much more heat, so much less efficient. So actually, let's just work with nature. Now, summarizing this up, and this is just a chart which comes out of this report, you can see the carbon potential impacts. So of all these 55 quests, they reckon there's nearly a gigaton of benefits between now and 2030, and possibly another 1.8 gigatons between then and 2050. And you can see the breakdown. But it's also interesting because what these quests come with is these quests come with economic activity, and they come with jobs. So again, just interesting. I think one of the things which we need to recognize, though, is that given where we are, it has to be and rather than or. So I don't think we can be in this mentality of saying, great, we've got 55 quests. Which one should we do? Let's do 1, 3, and 7. No, we're actually in a world where we need to be in the mentality which says we need to do all of these and we need to do more, because we started really at the beginning of this discussion thinking about the size of the challenge. So let me pause again at this point, because I've been talking again for another 15 minutes, and open up the floor for comments and thoughts and questions.